Hello, welcome to another part of building the roofs for our buildings. So here in Houdini, we have already a basic roof system. And what I want to do now is whenever I have a roof shape that is somewhat like this, like a basic square shape and has 2 points, I want to actually do another treatment here. I want to maybe skip this part because this makes basic roofs and I want to make another roof type of style. And you will see why I will have that. So this is actually an example why this basic roof system here is good at what it is doing, because you can put in some quite weird or odd shapes like this, for example, and it will still output like a nice sort of like believable roof somewhat. To sort of like find out if I can do a certain style or different behaviors on the roof, I'm going to make a wrangle to check what is possible. So I want to have a double check on my input shape, and just to be sure, like checking how many points are, for example, on my input shape. So we could, for example, grab our base shape and compare it to the poly expand and see how much more points we have, for example. But in this case, we will just, for example, use the edge distance. So what we can say is that if the edge damage, so at edge damage or distance, edge distance points, if they, for example, are bigger than a certain value, and you can also make this into a tolerance slider. So what if we have this as tolerance? So maybe we can say equal to the tolerance. So here, let's say tolerance value. Then what we want to do is we want to add this to certain groups. So I'm going to say add a new attribute. So add, and then we're going to just call it found top parts. And this is then 1. Or what we can say is we can directly save this to group. So we can just say group top points is equal to 1. And what we need to do now for this to fully work is to click on this part here. So we will have a handle and we can now set that distance. So here. So otherwise, basically 0 means 0. So we're just going to basically, as you can see, select everything that we have. So let's just give this like a small value. So we're probably going to get away with something just like 0.1. So you can see that this will all be 0 because this is just because this is 0, will return 0. We have a certain value here. So this is higher than that value, it will return 1. So here we're going to say like check top points, or just checking how many points are in the air or are higher. So this way I can know if we either have something that's a bit more complicated or something that's a bit more easy to work with, based on our result that we have from the poly expand, of course. So for example, if I would have a more complicated shape like this, you will see that we will have a lot more of these points in the top that we found. You can also then immediately have a group for that to select them. So based on that, I basically know that if we have a lot of them, then it might be possible to do something else or do something different. I just basically now would like to get the total amount of these, and we can simply do that by attribute promotion. So we're going to do attribute promote. We're going to promote that value, so the top found, to details. And we would like to have actually a sum of that. So we will just add those all together. So in our details now, we will basically now have 6 of them. So there are 6 points that are in the air. So I know that value 6 is actually a bit more complicated value to work with. So I'm going to rely on this part over here. So if we have our value, which is 2, then we do another subnetwork. So we then do here subnetwork. We can call this, for example, style A or whatever we have here. We can do multiple of them. And then what we want to do with that is we want to build a switch node, and we're going to switch based on what we would like to have or what is possible. So for my case, I'm going to switch back to a simple shape for now. So as you can see, now we have a basic shape like this, and I know that there are 2 points here in the air. So I know that I can actually now use this style. So this will be the safe option here to use. If the shape is too complicated, I'm going to use the base style. So we can here use that to switch. So let's now build the visuals for that. So let's go in here and write some logic. Now we are here in our network, and let's make some room. First process I'm going to do here is I would like to sort of like push this single point here to the edge of the other points. So we have like a roof that goes more in like a triangle and like a straight version of that. So I will use a trick for that. I will first place a enumerate node. So here we can place that. If you've never used this before, this will basically here in the attributes create a copy of your points. Or in this case here, it's set to by default to primitives. So we'll basically repeat the primitive number here. So we'll enumerate them. For our purposes, I'm going to switch here and use a point of that. So we're going to here make a copy of the points numbers. Then from that, we'll get to use a group promote. And we will promote the group that we just made, which was in Vex here. So the group that we made over here, which is called top points. We're going to use this here to say, I would like to promote this to edges. And we will now have this shape. But if we enable a certain toggle, I think it's this one, we will actually make sure that we're not going out the boundaries as you can see here. So it will only stick to elements that are in these bounds. So we will have this result now. And from that, we're going to do a edge to curve, which we used in the last video as well. And this will then give us one single curve here. On that curve, what I would like to do is I would calculate the polyframe, which will actually return normals. So we will here, instead of using normal name, we will fill in the normal in the tangent, which is something that we usually do. And what is special here, what I would like to do is I'm going to actually use here the centroids primitive. So this will make sure that actually our normals here, they will actually both look at the middle of my line. So if I quickly here say remove line, then you can see that we're just like facing both of these normals in the center of the line. So let's just quickly to visualize that. With that, I actually then want to reverse my normals. You can do it in Vex, or you can just do it with a normal node. So we can here don't compute any normals, and we're going to just say reverse them. So we're actually now having the other direction. So with that, we actually know, or we can actually do a raycast on how far should I go. And we're going to use the ray node for it. So I'm going to raycast to how far can we go. But we need to have a mesh to check on actually how far we can go. That's why maybe the second input could be useful here for our system. Is what if we could just here grab, for example, our base shapes after we did that cleanup. So here we can just say like so. We now have access to that base shape, and we're just going to simply do an extrusion on that. So here, poly extrusion, and fill it in like so. And we're going to fill in like a value like, let's say 50, something that's pretty large. And with that, we can now here do a raycast. So it will use the normals. So by default here, it will actually get the direction from the normals. As you can see, we can also do like custom directions, but it will get the normal value, which was this. And then it will just like see if it can find anything in that direction, which is of course that extrusion box. So we will have this result. So we basically calculate where we would like to see our points, but now how can we get this result now merged into this result? That's where our trick sort of comes into play. We're going to use the attribute copy node. So attribute copy, and we want to here use our enumerate value with our output of our ray value. And with that, what we want to do is we want to here, instead of using the color, we want to say, look at the positions, and then it will overwrite it. So by default, it might not work, as you can see. That is, we actually also need to say that match by attribute. And that's why the enumerate is here. So we will basically use index as a referencing value. So here we can say use attribute, and we're going to fill in index. And now, as you can see, we basically sort of like align these nicely on what we would like to see or expect from it. So again, like this is again using the index value, which is from the enumerate. So here it will just has these enumerate values as well. So it knows that the copy copy attribute knows that it only here needs to deform or copy attributes with index 4 and 5. And it will do that, and it will have a result like this. So this is how I can, for example, get something like this with like a nice trick to calculate that. Now, next step in my system is what I want to do is I sort of want to know which parts are actually a primitive with 4 points or with 3 points. So we can, for example, do that in a wrangle. So with a wrangle, we can set this to primitive. And we can write an attribute integer at connection, for example. So we can call it connections. This is equal to the amount a primitive has, or the primitive points. So if we would use the function called primitive points, this will basically return a array. As you can see, like this will returns a list of points. So if we do that, like here, so we're going to say look at itself and look for the primitive at the current primitive number. So this will not fully work because we need to actually convert this array to the full length. So we need to get the length of that array. So we're going to use a length function to get that. So now if we look here at the attributes here, we should have a connection number. So we're just like getting a list of all the points, and then we get the length of that array. And here I can just call it like get prim points, or points per primitive or something like that. So based on that, we can do a split node. We can split the geometry now in 2 parts. We can say here that at the connections, if they are equal to 3, we can split up the result like this. So now I have these split out. So I can invert the selection. Now I only have these parts. So with that, I can control or calculate different things a bit more. So what I will do is I will actually, for the triangles, I will remove them and I will instance a proper model of them. As you can see here on this image, I will sort of like properly place a certain piece on that triangle. And then the leftover geometry like this one will then actually just be my roof model. So we can start out with a simple one, which is then actually the roof model. So this part over here. And we can basically do very similar things on what you actually did on the previous base node, is that we actually just mainly need UV data. We mainly need to add some form of UV information. So I'm just gonna here and grab this part. So Control C and Control V that over here. So it should give us the same or similar result where we just have the UV based on our alignment. What we can also do is if we want to further control, for example, the height of this piece, we can still do a wrangle here because we might want to change the height based on maybe the certain model that we have for the triangle. So here what we can do, maybe we can even do it without the wrangle and just a transform. So if you place a transform, so in there we can actually just probably call the top points, and we should be able to then here move this up or down like so. So you could have done it in a wrangle and check on the points and build something more complicated, but we can just do it like so as well. I think that will be fine for us to do. So that's basically done. What could be interesting is with this roof system to also add groups and mark certain geometry pieces as certain data. So afterwards, if I merge all the things together, I can quickly get certain parts. So this is what I would call the roof tiles. So I'm gonna have it like that. This will then be my output soon. But now let's handle the other situation, which could be a bit more complicated. Here we have our triangles, and what we want to do is maybe do a clean up, depending on how much data there is on this. So it's not that much data, but you never know if you're going to input something from Unreal and do multiple things and build bigger systems. It might be interesting to always like check my data because I don't want to have like conflicting normals or scales. So sometimes I would usually just do like a full cleanup, and we just have a basic start here. Or you can always like say certain attributes to remove or not to remove. So from that, what I want to do is I want to calculate the normals. So I would like to know the direction of each triangle. So we can just say compute points, And then we here have just like the direction. So based on that, I can now like know roughly how to place that object. Now with that, what I will also like to do is to actually remove the point, the top point. So in this case, we actually would like to, for example, get the either the group, point group. So here we can, for example, say to either just like don't delete groups at all, since I don't have that many groups here. It's like only it's currently the only group in the geometry. And what I can say is just blast this away. I can also make a vex part where I would like blast away certain parts. And now we have these points. Now, what I don't like about doing this blast node is that we actually also get rid of all the lines or primitives that we had. So I'm going to convert my primitive and do a convert line node. So this will create a bunch of lines out of them. So we don't have like an actual solid primitive. And then we can just do our deletion and then we still have that line. This is the final information I would say that I need for this to work. So I can now, for example, calculate the middle point, and I can also calculate the length of the line. So I know how to scale up my model if I place something there. So we probably should have the rest length available. So the convert line will also calculate the length. So if we go here to rest length, it's 8.8. And we probably want to promote this value. So attribute promotion from our primitives to the points. And let's say here rest length. You can also rename this to width or length if you want to have something a bit more understandable. So we should see it over here as well. Now, based on this rest length value, I want to copy either a small, medium, or large model. So I have three different sizes of that. And in this case, I'm going to take a different approach than I would maybe usually do. We're going to use a node called attributes from pieces. And this is a quite recent node. It's not that old. And what we can do with this is we can define things based on the rest length value. So to keep it simple for now, let's just add an add node. And let's give this like one single point over here and plug it in over here to just have the node working. So I'm just going to first explain a bit more about this node, and then I will continue on the setup. So what this node needs is we're going to change the mode from cycle to map attribute. That will make sure actually the menu will change. So we can actually now map attributes. And that's what we're also going to do. So we're going to map attributes based on input A and B. Now here we have our attributes, which is P scale. We probably want to change this to our rest length. And we want to map from actually a specific range. So that's basically what we want now. So right here, we can set our ranges manually. So we have the autofill, but I have not really set up anything. So here we can, for example, click 3 times. So we have here a small, medium, and large piece. So let's say when I have the small piece, our value of the rest length should be between 0 and 1 in this case. Or we can, for example, say 0 to 4. Then we're going to move over to the other one. And we're going to, for example, call this medium. And medium values means that our rest length should be in a value between 4, because of course we need to continue here, 4 and 8. Then we can, for example, say that the large pieces are from 8 to something very large, like 20 or even 30. You can like make it pretty large, but I think 20 is already like a very large number. So currently with what we have, the large part will be picked because our value of the rest length here was 8.8. So we will here pick the large geometry one. Now, currently this is not fully working because here in our second input, we need to actually define a bit more about what the small, medium, and large part are. But this is basically how the menu works. So we're going to have to say, look at this attribute. And if this attribute is between a certain value, then we're going to either pick the piece small, medium, or large. So that's how that is done. Now, what we need to do here on this side is we need to simply create an attribute. And here we're going to give this the name. And this is then a string value. And this is, again, just called small. So what this is actually now representing is, again, name is actually used here at the top. So this is the attribute, again, to also look at. So name, and then small is then referencing to also this piece. So I need 3 of them. So we have like small, medium, and large. And we're gonna merge it together like that. And this is then my input. And as you can see now, here we are getting the large value. So that's our result now. So if you want to test this out, you can just place, for example, a transform node here, and we can play around with and the scale. So I'm going to here lock my attributes for a moment. And if I would play around with the scale, we can see that we can go from medium, medium, small, and large. So again, based on the size that we have, we will automatically switch to these pieces, which is pretty useful in multiple cases. So of course, you're not limited to use like only these 3. You can do multiple things. You can even, I think, fill in multiple results here. So you can do multiple things with this menu. So for now, we set it up correctly and we can now use it further in our system. So next thing to do here is I would like to calculate the middle point. So we can do it, for example, using a resample node. You can also do a fuse node, but then you have to make sure you're not fusing these too close to each other. So with a resample node, we're not going to use here the segments. We're going to use the maximum segments based on number. So let's say 2, because it will only create 1 here in the middle. We can also use the curve view value, which will be useful in a moment. So the curve view value is pretty useful. It's found here somewhere. Oh, my attributes are still unlocked here or toggled. So the curve value here will return a couple of values. So by default, what will happen is it will sort of like take your line and it will, for each point, give it a certain number from 0 to 1. So 0 meaning the start, 1 being then the end of the curve. So in this case, since I have 3 points, we basically will have 0, 0.5, and 1. So if I would like to extract a middle point, I will basically have to say that everything that is as a value 0.5, we need to extract, which you can see over here. We have these 0.5 values. So 0 is the start, 0.5 is the middle, and 1 is then the end of the curve. So we're going to here use a delete node. So delete. Then in there, we're going to say delete by an expression because we want to sort of like make a small if statement. So we're going to say that, hey, if our curve view would be equal to 0.5, we can delete it. So make sure, oh, I mistyped it. It's curve u. And then, of course, like I already filled in my expression, but first of all, I actually had to set actually this to points. So now it's actually deleting the other one, and we're going to have to say delete non-selected. So we now have the middle one. So yeah, of course, this is of course stored in points, so we have to make sure to look in points. And then we're going to have to say if the curve view is equal to 5.5, then we keep them. Then next up, what we're going to do is we're going to just place a wrangle now. So wrangle, and what we're going to do here is we're going to actually set scale based on the attribute sizes here. So I have 3 possible options with 3 possible models, and I want to actually tweak the scaling based on what they have. So in this case, I'm going to do it in a wrangle. We can again do it in other ways. So we're going to just say if my name of that model would be equal to, for example, the small parts, then I can do certain logic. So in this case, I would like to define the model scale. Oh, maybe I need to actually create an integer, a float for that. So float, and I'm going to copy this for now. So float model scale is, for example, by default 1. So let's now continue here with this statement. So here, maybe let's grab that. So if our model is the small one, then basically our model scale is then, for example, 4. Then I'm going to just copy paste this, and I'm going to copy paste this 2 times. So for the medium and large. And then we're going to have to change these scalings. So from what I know is that this will be 6 and this will then be 8. So these values are definitely like targeted on what I actually filled in here somewhat. But they also are based on the values that I actually have on my models. So when the artist actually made these models, they are specifically built with size 4, 6, and 8. So I'm just going to use that over here. So now that I know this value, I'm also now need to look at my rest length. So it's important now to understand that currently I'm using the large model, which the default size or the actual size of the model is, for example, 8. So I can see that my line is a little bit longer. It's actually 8.89. So I actually need to have a scaling value with that. So when we send this to Unreal, we actually need to scale this up. We actually need to scale this model by a little bit. So we're going to make sure it's right. So we're going to say add RP scale value is equal to the rest length, which is that 8.8 value, divided by the model scale, like so. And we will now create a p-scale value that's a little bit bigger than 1, because again, our base model is size 8, and we need to scale this up a little bit to make sure that we have the same value of our actual line that we have here. So this line, so we are matching up with the size. Now, final thing to do here is creating instances. So we can use the labs instancing tool. So here we're going to fill in our instances then in a moment. Now, before I'm going to do that, I'm actually going to blast and split our results based on the sizes that we have. So we're just going to say here at name equals to, for example, small. We will only then have these points. So I'm going to make sure we are actually looking here, first of all, into the points. And we also have to make sure that we are now deleting non-selected. So now we should have nothing there. So I'm going to copy this for then the medium. So medium, and the other one is then the large part. And then this is where we should actually then see our points back again. Then for each part, we're going to just include a instancing value or an instancing node. And this will include some basic values, as you can see here. Then we can merge this together because it doesn't matter that much if the result is, for example, nothing. We can just merge them all together. And what we also can do is we can make a group node. And we can call this instances. We should probably make this a point group node since instances are often just points. So here we are just having that group. So with that, we're going to merge the results. So we have our instances and we have our actual new sort of like roof shape. So we have something like this. So we have the geometry and then we have a point for instancing. And this is then my output over here. So last thing here is, of course, then the switch node. And what I'm going to do here with the switch node is I'm going to create a spare input. So here we're going to say add spare input. We're going to use the promote here one. And what we want is we're going to basically would like to check on the amount of points found. So here, this part. So we're going to say, look at the details of our spare inputs, which is -1. Then we have to say which attribute and the index. So look at the value called found top points, so found top, and index 0. And if they are equal to 2, then we can switch to this style, so it's immediately already working. So you can see it's now using this style. So whenever this is not equal to 2, we're going to use the other style of buildings. So here, if I would quickly here grab my cubes and would play around with that, we can see that we will now have different results. So we have these roof shapes. You can also see that the roofs are a bit strange in each other, and that's probably because of some of the steps that we also did over here. So this actually needs a bit more cleanup, I would say. So these shapes need a bit more cleanup to also have proper results. So if you want them to be fully merged with each other, I would recommend doing some cleanup pass here with like a fuse or something. But I think this video is already long enough for now. And I will talk about it in another video. This is then basically where I'm going to finish off the room logic. And next video, I'm going to do one more video, and that's basically about bringing this into game and making sure like some little things are tweaked to have this nicely in game engine. So I hope you enjoyed it, and thank you for watching.